In this section, I'm going to show you how to use the bisection method for root finding. But first, what is root finding? Root finding is the problem of finding the value for a variable that makes a function go to 0. So for example, if we had the function f of x equal to 2x cubed plus x squared minus 5x plus 3, and we wanted to figure out what value of x made that equal to 0, that problem is a root finding problem. Root finding is useful in a variety of situations. For example, if you wanted to figure out what is the square root of 2, you could do a little algebra and turn this into a root finding problem. If we squared both sides, simplified, and put all the terms on one side so that the entire equation is equal to 0, now we found a function that we could apply a root finding method such as the bisection method to. And because this function is algebraically equivalent to this function, the x that sets this function to 0 will be the same x that is equal to the square root of 2. Now let's apply the bisection method to find the root of our function f of x is equal to x squared minus 2 equals 0. And let's remember that x is going to be equal to the square root of 2. Now if we were to plot f of x, it would look something like this. Now to apply the bisection method, first we have to find two x's that are bisected by the root of f of x. Now note that the root of f of x is the place where f of x is equal to 0. So let's pick two x's. Let's pick x equals 1 and x equals 3. Clearly the root is between 1 and 3. Let's call them x1 and x2. Numerical methods for root finding usually involve picking successive x's that get you closer and closer to the root. In the bisection method, your next guess for x will be the average of your two bisecting x's. The average of 1 and 3 are going to be 2. So let's pick this as our next guess for the root. Let's call it x3. And we're going to keep on taking averages to get closer and closer to the actual root. Now we're going to figure out which of our x guesses the root is between. Is the root between x3 and x2, or between x1 and x3? Clearly the root is between x1 and x3, so we're going to pick these two x's as our bisecting guesses and take the average. Let's call it x4. And we're going to keep on doing this, getting closer and closer to the root each time. Now which x's is the root between? Clearly the root is between x1 and x4, so take the average. Let's call it x5. Let's do it just one more time. The root is now between x5 and x4. We're going to take the average, call it x6. And let's stop there. As you can see, x6 isn't an exact guess for the root, but it's pretty close. To sum it up, the bisection method requires that you first have two guesses bisected by the root. Then successive guesses are made, which get us closer and closer to the root. The key to making a good next guess is choosing which x's you should average. And the way to do that is to figure out which x's are directly on either side of the root. A quick note that will make it easier to code this up. At the root, f of x changes sign. So either f of x goes from negative to positive, or for a different function, f of x might go from positive to negative.